Hi viewers, welcome to NCK Hub Consulting and Training. As part of our Java 8 playlist, in today's video, we will be discussing on optional classes and method references. So we will start our discussion with optional classes. What is optional class? So they have introduced a new class called optional in Java 1.8, which is a kind of wrapper classes which either contains a value or it might not contain a value. So if it does not contain a value, we'll be calling it as empty class. So basically, what are the types of values that these classes will be holding? Potentially nullable values. So this was basically introduced to make programmers' life easier in handling the null pointer exceptions in an effective way and very controlled way. Compared to our traditional programming, which was there before Java 1.8, the usual null checks that we do across each and every objects that we declare or create in our code, we can replace those all null checks using this optional classes. But this is not a complete replacement for null, but rather it can be considered as a tool that can handle the null pointer exceptions in a very controlled and effective way. As this particular optional class is going to replace all the traditional null checks, this will help us in increasing the code readability. And also, this optional class, when it was introduced as part of Java 8, they have also integrated this particular class with all the frequently used libraries across Java and its frameworks. So this is very important in whatever framework that you work, like Spring Boot, Spring MVC, in all those cases. So in each and every framework that is directly related to Java, this optional classes was integrated. Okay. Now let us see what are the ways that we can create an optional class object. So basically, we rarely use this particular concept of creating optional on our own because most of, as I mentioned earlier, this optional class was integrated with almost most of the libraries which we use in our regular programming. And most of the cases, we get the response of those methods as an optional class object itself. And we will be using all the other API methods on those objects, and we rarely use the concept of creating an object optional class on our own. But since we need to know how to create an object for an optional class, yes, we need to understand that there are three ways in doing it. What are those? One is optional dot off method, and another one is optional dot empty method, and the third one is optional dot off nullable. So the very first one, optional dot off, it will create an optional object with a non-empty one. And the second one, optional dot empty, will create an object for optional class, which is an empty optional. And the third one, it will allow us to have a null value as well. The very first one will not allow us to have the null value and it is a non-null. But the third one, it allows us to provide the input as null also. So whenever we pass that as null, the JVM will indicate that as a empty optional class. Let us go to the coding part to understand better. So here is a class that I created. The class name is create optional. And inside that we have three approaches. This is the very first approach, optional dot off. And we have the second approach, optional dot empty, which will create an empty optional. And the third one is optional dot nullable, which will create an option. And this will have the in this will accept the input as null. We can pass the value also, like how we are passing here. But here null is not allowed. Here null is allowed. That is the difference. So these are the three ways that we can follow in creating an optional object. And next, what are the possible ways that we can use to check the presence of a value in the optional object? So if you see the programming example here, I have provided three references. One is using empty, and another one is using is present method, and third one is using if present method. So here this is present, and here this is if present, and the very first one is empty. So this is empty will return a Boolean value, and this will return true if the optional object is empty. And if at all there is something available in that object, it will return as false. So for that reason, I have added a not condition here. So not false means it will return as true. And here it will go inside this if condition and it will be executed. And whereas the second one is present will return true if at all that optional object have any value in it. Since I have already created an optional object using hello world as a string, so it is clear that there is a element already inside the object. So this will be default to true here, and it will execute it. And the third one we have is if present. Similar way, if present is also true here because I created an object by passing a value, and it will be printing the value here. And this is a concept of lambda expression which I am using. Above two methods are the traditional programming approaches, like the same if conditions we are using. And the third one here is using the lambda expression. Let me execute this program. We will see the difference. So in all the cases, we are getting the output. Okay. So these are the ways we can use to find out whether there is an whether there is a value available in the optional object or not. Now let us go to the next concept. There are few other API methods that we can use from optional class, and these methods are used for handling the null scenarios. Let us say here we have this option. The third approach which we used for creating an optional class object, and we are using this one and passing null as input. So this will be created with null and it will be automatically an empty object. Now we have an option to tell the JVM how to handle that. So if at all you find or you come across a null object with optional class, you can provide to have a default value whenever you get come across an empty, or you can also provide a supplier which will be executed wherever it is needed, and the supplier will provide us an output as discussed in our earlier videos. And there is one more option where you can throw an exception. So exception can be a runtime exception, and runtime exception is default here. No such element exception will be there, or you can give your own custom exception as well. Now let us see all these three methods in detail in an example. So these are the methods that we have here, API methods. And the very first one is or else. So I created an optional class object with value as null inside this, and I am asking the JVM to consider as a default value if at all there is no value inside this object. And for the second case, I am passing a supplier, and this is again a lambda expression. I am not passing any inputs to the supplier because supplier will not take any inputs. Instead, it will execute some logic and provide us the final output. So I am asking the JVM to, as part of the supplier execution, I am asking it, I am not providing any explicit logic, but I'm just providing like supplier provides the default value. So this will be the output of the supplier. And the third one we have here is or else throw. So if there are no arguments provided, it will go with the default runtime exception, which I have shown in the slide. No such element exception. If at all if I want to provide some custom exception, again I have an option to provide as a parameter using the lambda expression. So this example will not have any inputs for this or else throw method. So JVM will take the default runtime exception, which is no such element exception. But on the next example, if you see, I try to customize the exception using the lambda expression, and I am asking the JVM to provide the illegal argument exception. So for the very first execution part, what I'll do is I'll comment this out and then I'll execute it. And for the first two cases, you will be seeing the output. The first case, you will see the output for the default value, and for the second one, you will see the output as the supplier one, whatever we are getting the return from the supplier. And for the third one, you will be seeing a exception being thrown with the runtime exception, whatever here it is. Let me execute this program. So for the first two things, we got the output. For the third one, no such element exception was thrown. Now what I'll do is I'll uncomment the last one and I'll comment this. Now let me execute. See, earlier we got the no such element exception. Now we are getting java dot lang dot illegal argument exception. This illegal argument exception is the customized exception which was written in the code. So we customized it. And that's the reason we are getting it as exception. So using these three methods, or else get, or else throw, you can provide instructions to the JVM to handle the empty object optional classes. So this optional class is very much useful when you deal with the database interactions or some framework related applications where we cannot anticipate or predict the null pointer exceptions. So unpredictable null pointer exceptions can be easily handled using these optional classes because for whenever you get an optional object, we definitely have to follow or use the methods which were having the logic of checking the presence of the value inside the optional object. So whenever, if at all there is a value inside the optional object, then only the execution will go, or else the execution will not go. So that way, all the null pointer exceptions will be addressed very effectively. And hope I'm clear on the optional class part. Now let us see one more example with respect to the optional class. And this one, if you see, first let me uncomment this and let me comment this line. And also I'll comment this line. Okay, so if you observe this particular example, inside the main method, I have created a string array with the 10 size. Okay, I did not initialize to any of the value inside the array, so the default values will be null. Now, without initializing any of the arrays, in any of the value inside the array, I'm just trying to convert the one of the string at the index 5 to lowercase. So in this particular scenario, JVM will throw an exception because without initializing, I'm just trying to convert a particular string in an index 5 or to a lowercase. Let me try to execute this program and see how it happens. So if you see, we are getting a null pointer exceptions. So usual traditional programming is if at all you are doing any operation on a string object, you need to first check whether it is null or not. And if it is not null only, you will be able to do this particular logic. So let us say we forgot to do that and we ended up with null pointer exception. Now what I'll do is I'll uncomment the optional logic part and I'll comment this particular part. Okay. Now what I'm trying to do here is I'm just trying to check first whether it is nullable or not. Okay. And we got an optional object. And after that I'll check whether this particular optional object is having any value or not using isPresent method. If at all the value is there inside this, then it will go inside this because the return type of isPresent is a Boolean value. Okay, and if at all there is a value present inside this object, we will be getting a true. If not, we will be getting false. Now what I'll do is No, we are checking in line number 21. We are checking for a value is present inside the object or not. If the object is present, we will be getting true and it will go inside this. And if the object is not present, it will go inside the else. Since I have tried this, executing this without initializing anything, this value should be false and I should be getting this in the output. See, if you see here, I got the output in the else part. Now what I'll do is, I'll initialize the fifth element and then I'll try executing the program. Now if you see here, I got this because this value will be true now because here we initialized it. So this is having a value now and that value was stored inside this object. And when I checked this if condition, this is true and it will come inside this. And here we are printing the output. And this particular value was displayed in the output. So this is the advantage of having optional logic. Maybe more if you practice in the streams and collections, combination of streams along with collections and some advanced frameworks like Spring Boot and other things where you do Spring Data JPA operations. Optional will be more familiar to you people. So this is all for optional. Hope you are clear on that. Now let us go to the next concept, which is called as a method interface. Yeah, what is a method interface? The process of providing references to pre-existing methods is known as a method interface. Method reference, sorry, not interface, method references. Maybe the definition might be a little confusing. We'll go in deeper to understand more on this. So, what is the operator that will be used for doing the method references? Double colon operator is used for dealing with the method references. So, how many types of method references are there in Java? Three types. What are they? Reference to a static method, reference to an instance method, reference to a constructor. So, three types of references are there. How do we handle each and every scenario? We will go in deeper with respect to the examples. Okay. So we'll start with static method references. So in this example, I created a class with static method references class. And here we have a interface where sayable is the interface name. And this interface have one particular abstract method. So an interface with one particular abstract method is called functional interface. Okay, here we have one interface. What I'm trying to do is inside the main class itself, I created a method called say something, and I have provided an implementation as well. So if you remember our logic of providing the implementation to the functional interface abstract methods, we usually follow the concept of lambda expression in doing that. Here, just for a change, we are using method references and I am telling the JVM for this particular interface for whatever method, the abstract method that was there in this particular interface, you can refer to the method which was the one I am providing here. So this is the class name and this is the method name I am providing you. For a implementation of this particular method, you can refer to the logic which is available here. So what the JVM will do is whenever you make a call to that particular method using this interface name, and whenever you make a call to that abstract method which is there in this particular interface, JVM will go to this particular method and it will try to execute and it will try to provide us the response. Similar way, let us take another example, which was concept of multi-threading. So whenever you create a thread inside multi-threading concept, we usually implement the runnable interface. And with the concept of lambda expressions, we usually provide lambda expression here and we'll start the thread. That was the process that we followed earlier. Now what I'm telling to JVM is instead of using the lambda expression here, I am asking the JVM to take this particular method inside this particular class as a reference and then start the thread. Okay, now let me execute. So here if you observe, I am bringing through two threads here. So one is a main thread and here I am passing the thread name. So basically I am trying to print the thread names to the console just to have an evidence saying like there are two threads. Even though we did not implement the runnable interface either using anonymous inner class or lambda expression, but still using the method references, we were able to handle it. And we can see two threads also. One is a main thread and another one is the thread that we created here. Let me try to execute this program. So if you see here, for the very first one, since in line number 16, I called this same method. I got this hello, this is static method from say something. And after that, the main method was started. Main method name was got here. The name of the thread is main thread. And after that, the thread is running. And what is the thread name is thread 0. So another thread was created here. So even though I did not explicitly implement or provide implementation for runnable interface, either using anonymous inner class nor or lambda expression, but still using the method reference concept, I was able to tell the JVM to use a particular JVM as a replacement for a abstract method which was there in runnable interface. What is the abstract method that we have in runnable interface? Run method. So hope we are clear on the static method references. Now let us go to the instance method references. So instance method reference is also pretty much the same. Only difference is there I have used directly the class name. Now here I am using the instance variable by creating an object for the class. If you see all the implementations are same, but here the methods are non-static and here in static ones the methods are static. Apart from that, implementation wise, everything is same. And inside the main method, in the static method references, I tried to refer using the class name directly and the methods. But here in instance method reference part, I created a reference object here. And using this instance variable, I am trying to refer to the methods. And apart from that, the implementation is everything the same. Let me try to execute this program. There is no change at all. So for this one, I did not include the sysout for the main thread. That's the reason you did not see a main thread here. But apart from that, you have an evidence here showing like there is a new thread created. So this is for the instance method reference. And the last method reference that we have here is constructor references. So for this, for explaining this constructor reference, I have taken another interface which is messageable interface and another class called message class. Okay, this message class will have only one particular method which is message, and it will take one argument and it will give us a out here. That's all. We don't have anything. And here in messageable interface, we have a abstract method with the return type as message and the method name is get message, and it will take one simple argument, string argument. What I'm trying to do is for this particular constructor, I'm trying to refer this particular class constructor as the implementation to this method inside this constructor reference class. If you see the line number 6, messageable is a interface name, and this is the object creating for the interface, and this message is a class that we have here, and this is the constructor for it. So what we are trying to do now is we are just trying to refer to the new method, I mean new keyword. A new keyword will automatically refer to the constructor at the backend. So what we are telling to the JVM is for an abstract method which is there in this particular interface, if you are looking for an implementation, whenever I call this method, You go to this particular class, refer to the constructor, whatever we have here, and get that constructor executed. Okay. And we are passing the input as constructor reference. And using this object, whatever we created, we are trying to call the method that is there in the interface. Now let me try to execute the constructor reference. See, now we got the constructor reference. So what we are doing here is using this particular interface here in line number 6. For this interface, we are creating an object. We are asking the JVM to go to a particular class, and we are directly referring to that class constructor itself using the new keyword. So we don't have any other methods other than the constructor in that class. So we are giving a new keyword here, telling the JVM to go to a constructor which is there in that class, and then consider whatever logic is there in that constructor as a execution to this particular method whenever it was called and give us the output. So that was what we got here. When I tried to execute this again, we got the response. So hope I'm 100% clear on optional class and method references in Java 8. That's all for this video. Thanks for watching.